Okay, so hello people. So today we'll be solving LeetCode daily question 1481, that is least number of unique integers after a removal. And in this, we'll be given an array of integers ARR and an integer k. We have to find the least number of unique integers after removing exactly k elements. Okay, so for example, in this array we are given 5, 5, and 4. So we have to remove exactly one element. And if we remove 4, so that after that we'll be left with 5 and 5. And that's the only element, and that's a the least number of elements that we can have. In the next test case, we are having like 4, 3, 1, 1, 3, and 2. So after removing 4 and then 2, and then either of the two, either one of the two ones, or either one of the three threes, we'll be getting the output as 2, because we'll be just left with 1 and 3. Okay, so what we can observe from this question is that we will be having like we can just remove the elements with the their least number of with the least number of frequency. Like for example, in this 4 is just occurring one time, so we'll remove this. And in this we can first remove 4, then we can remove 2, and then we can remove either of the 1 and the 3. Okay, so let's just solve this, and let's have a map for integer comma integer. And yeah, I guess, yeah, and let's call it frequency map. Okay, frequency map, that is equal to new hash map. And then let's just put the values from the array into the frequency map and updates frequency. There are map dot put num comma frequency map dot get or default num comma 0 plus 1. And then what we'll be doing is we'll be having a priority queue, or you can just store them in the integer also, but I'll be having a priority queue of, let's call it min heap, that is equal to new priority queue. And let's just fill this priority queue with the values of the frequency map. Okay, I'll just show you like a base solution. That is, what we'll be doing is, if we are having a brute force kind of solution, that is, if we are having A and B, the two elements in the priority queue, we have to sort them on the basis of their frequencies. Okay, so the elements with the least frequency will be sorted first. Okay, so map frequency map dot get A minus frequency map dot get B. Okay, and then we'll be adding the elements into the frequency map. Okay, then for okay, not for, yeah, that for end key in frequency map dot key set, frequency map dot key set. What we'll be doing is we'll be adding it into the main heap, that is main heap dot add key. And then we'll just use a while loop, that while heap is not empty, not min heap dot is empty, and my k is greater than 0. So what I'll be doing is I'll be removing the frequencies from the k, that is like k minus equal to frequency. I'll be removing the occurrences from the k, because that will be the number of times I'll be removing that particular element that is present at the top of the main heap, and that will be obviously like the minimum element from the array. So min heap dot is empty. Okay, so I'll be just doing frequency map dot get heap dot min heap dot pole. Okay, and at the end I'll just return the size min heap dot size. Okay, so now let's run it. Okay, so it's let me just check. Oh, okay, sorry. So what I have to do is I'll be checking that if my k is equal to 0, that means I can remove all the elements. So then at that time I have to return the main heap size of the main heap, or otherwise I have to return as main heap dot size plus 1. Okay, so now let's run it again. I guess this should it should work. Oh, sorry. Yeah, here it should. Yeah. Yeah, and it works fine. Now let's submit it. And it gets accepted. Okay, so but there's a better solution to this. So if we notice that what's mattering the most are the frequencies only and not the elements. Okay, so we'll not be needing this. We'll be just creating a priority from the values from it at frequency map dot values, and we'll be creating a priority from it. We don't need this anymore. And let's have a variable, let's say elements, that will be keeping the track of my elements that have been removed. Let's say initially it's 0, and then while not min heap is empty, and in this case we don't need this condition. So what I'll be doing is I'll be just removing the frequency that is present at the top, that is k is equal to heap, k minus equal to heap dot pole, and other and if any instance I'll see that if my elements removed, oh sorry, elements plus equal to yeah, I have to add elements plus equal to elements removed plus equal to the frequency that is the element that is present at the top of my heap, that is min heap dot pole, and at any instant I'll be checking that if my elements removed becomes greater than k, at that point I'll be returning my size of the main heap, or else I just have to return, I guess, 0 in this case. Yeah, if I'll be just returning 0. Yeah, now let's run it. Okay, so let me just check it. Oh, so okay, so I guess I should not remove it here. Instead, I should heap dot pole. Yeah, and now it should run. Yeah, and it gets accepted. Now let's submit it. And works perfectly fine, and even better, like we improved almost 50 milliseconds of the time complexity. Okay, so this is it for today. Thank you for watching.